Hello, in the last videos we discussed about binary search and some questions. Let's discuss the next one. Pause the video and give it a try. Given an array of n integers, find the number of subarrays such that removing that subarray creates a non-empty array that is sorted in increasing order. So given an array, we have to remove some subarrays and we have to find number of subarrays such that when it is removed, the new array formed will be sorted. Before solving this, let's solve a modification. Given an integer array, remove a subarray such that remaining elements are not decreasing. Return the length of shortest subarray to remove. A subarray is contiguous sequence of array, and the length can go up to 185 and the values can go up to 186, 189. And if the array is 5, 4, 3, 2, 1, since this is strictly decreasing, the length of subarray we can remove is only 4, and it is contiguous, because if we try to remove a subarray with length less than 4, the final array will consist at least of 2 elements, and as this is strictly decreasing, we cannot find such a subarray. So the shortest subarray we can remove is 4, so the answer is 4. So the question asks us to find the least subarray that to be removed. So instead of that, let's try to find the largest array we can find, and which is final, which is sorted when we try to remove the subarray. So given an array, let's try to remove some subarray, and let's try to maximize the length of the remaining array which is sorted. So then final answer will be n minus largest, because largest is the number of elements in the final, and the subarray length that we are removing is n minus largest. So let's take an example which is 1, 2, 5, 2, 3, 4. And let's say the prefix, this part is sorted, and this part is also sorted. So let's try to traverse the prefix and try to find an index j which is suitable for present element. For example, we are traversing the prefix and sorted prefix, and we are at this element. So if we are at this element, all elements before are sorted, because we are traversing only the sorted prefix. So if we are at index I, all elements before this will already satisfy the condition that it should be sorted. So we are at this index, and we are trying to find the index where the sorted condition will be satisfied here as well. So for example, if this is 3 and if it is 2 and 4, we want 4, because only then it should be sorted. It will be sorted because this is also sorted, suffix and prefix is also sorted, and we are at index j and before elements are sorted. So if we are at this prefix and we want some suffix such that it is greater than equal to this element, greater than equal to v of j, where j is the index of prefix we are at. So if we find a index which is this, the condition will be satisfied such that we are finding the maximum final length. So let's say we are at index 1 and we are removing nothing. So final array will be this, and this is not sorted. So this will not be our final solution. And if we try to remove the first element, the final array will be 1, 5, 2, 3, 4, which is not sorted. And if we try to remove 2 and 5, we are trying to remove contiguous subarrays, and we are trying to find which satisfies the final condition. So if we try to remove 2, 5, the final array will be 1, 2, 3, 4, which is sorted. And if we try to remove 2, 5, 2, it's sorted. It is sorted as well. It is sorted as well. So similarly, if we are trying to find the condition at index 2, we are removing nothing, so it is not sorted. And we are trying to remove 5. This is sorted because 1, 2, 2, 3, 4. And if we remove 5, 2, then also it will be sorted, and so on. So the first observation is, if we try to find the least index which will satisfy it, for example, if we are at index 1 and the least value, least index when the array will be sorted, if we try to remove the middle subarray, so we are at 1, and if we try to remove all elements before this, the element will be 2, because we are removing subarray 2, 5, and the final array will be 1, 2, 3, 4. So only then the condition will be satisfied. And if it satisfies for index j, it will be satisfied for all next indices, because this is the index and this is suffix index. If we remove this, the array is sorted. So if we remove this, it will be surely sorted, because the suffix is also sorted. So if we try to find the least index, in that way the final array has maximum values, and in that condition we can remove the shortest length. So if we observe in any case, for example, let's take this, and we are finally at index 2, index 4, and we are trying to remove this. So initially we are not removing anything, it is not sorted. And if we have to remove 3, even then it is not sorted. And if we have to remove whole, even then it is not sorted. Any indices are not satisfying for this. Why? Because initially the prefix is not sorted itself. So we cannot try to keep this prefix in the final array. So we have to traverse only the sorted prefix, so that we can find the element which is greater than equal to that, so that we can find the maximum final length. So for example, if the vector is 1, 2, 3, 10, 4, 2, 3, and 5, if we try to remove 3, 10, 4, the maximum length will be 5, which is the maximum of all possible cases. So let's try to remove the subarray I to j. So if we are removing I to j, what are the elements in the final array? v0 till vi minus 1 and vj plus 1 till vn minus 1 because removing the middle subarray. So let's assume that this will satisfy the final condition. So it is sorted. So v0 less than or equal to this and so on. So we have to find the least index where the subarray is sorted, because we discussed that if we try to find the suffix that is sorted with least index so that the maximum suffix is sorted, we can try to use at index j in the prefix and we can find some condition so that the final array will be sorted. So we have to find the least index int where subarray, the suffix starting from int is sorted. So if we are at index j in the sorted prefix, we want the element which is greater than or equal to this, because we are trying to remove the middle subarray, and if we are removing this, the final array will be 0 to j and from this to this. So this should be greater than or equal to. So by using lower bound, we can find this. So if you are at index j and if we want to try we want to get the least index which is greater than or equal to this, we can use lower bound. And we have discussed that it is already sorted, so we can use lower bound. So if index is equal to 0, it means that whole array is sorted. So if there is this the same array and 1, 2, 3, 10 is sorted and 2, 3, 5 is sorted as well, we want lower bound in only some suffix which is sorted. Lower bound of v dot begin and v dot end comma x returns the iterator which is greater than or equal to x in the whole array 0 to n minus 1. But we only want lower bound in some sorted suffix so that only it is sorted and our condition will satisfy. So we want search space index to n minus 1 because index is the least index that is sorted, and so that maximum elements will be left. So lower bound of v dot begin plus end and v dot end will give the lower bound of x in the range index to n minus 1. So this is what we want. So we can use lower bound of v dot begin plus end and v dot end. And we missed the condition that the prefix array is sorted. The prefix array is sorted and this is not sorted the middle part, and the final suffix is sorted. So we are traversing the prefix and we are trying to keep some prefix surely till index j, and we are trying to find the subarray for next part. But what if we try to keep only as the suffix is sorted? The final array can be any of the subarrays of sorted suffix and similarly prefix as well. So answer is equal to max of answer comma element index. So we discussed that we are finding the maximum length of the final array. So if we are trying to keep only the final array as sorted suffix, we can remove the whole subarray from 0 to index minus 1 and the final array will be indexed till n. So one of the possibility of answers is n minus index because we are keeping the array as index to n minus 1. So the length will be n minus index. So final array is 0 to n. So the final array we are removing is 0 to n minus 1 and the final array is indexed to n minus 1. And similarly the prefix is sorted. So we can try to traverse the prefix, and if the prefix from this to this is sorted, this can be one of the possibilities of final array as well, so that we can remove this. So what is the maximum length that we are trying a possibility to keep for the end? It will be j plus 1 because 0 to j is sorted and we are trying to keep this as the final array. So what are the possibility of length? It is the length is j plus 1 because j minus 0 plus 1. So final array will be 0 to j and the array we are removing is j plus 1 to n minus 1. So we are traversing the array and we are trying to find what part of prefix is sorted and similarly what part of suffix is sorted. So we are starting from 1 because 0th index is single element and is already sorted. So if the previous prefix is sorted and v of j minus 1 less than or equal to v of j, so if this is greater than or equal to this, again this also will be sorted. So ps of j will be 1, and if any of the condition fails, ps of j will be 0. And similarly we are trying to traverse from last but not index because last index is 1 and it is surely sorted. So if the next part of suffix is sorted and v of j less than or equal to v of j plus 1, so if the element is 3 and the next element is 0, it will be not sorted because we want greater than or equal to elements. So if it is less than or equal to j plus 1, then yes, it is sorted. So ss of j is equal to 1, else it is 0. And we want the highest index, least index int such that ss of j is equal to 1 because then only it will be sorted. So we are traversing from last index, and if ss of j is equal to 1, index is equal to 0, index is equal to j, because we are updating index as we are traversing so that we can get the least index where it is sorted. Sorry. And the final solution will be we can traverse the whole array, and if the prefix is sorted then traverse, else break the loop because there is no meaning to traverse if the present prefix is unsorted. So answer is equal to max of answer comma j plus 1. So this condition represents that the final array we are trying to keep is 0 to j, which is a part of prefix. So, and now we are trying to find lower bound of v of j, and it will be v of begin plus end and v of end, and the value will be j plus 1 plus n minus lower bound, because we are at index 0 and we are trying to fix the final array till this in the prefix, and lower bound of this is lb, and the final array will be 0 to j and lb to n minus 1. So the length of this will be 0 j plus 1, and length of this will be n minus lower bound. So this is the maximum length that can be final, and the length will be n minus answer which we have to return. So we are traversing the prefix, suffix and final array, and we are finding the lower bound and finding the answer, and finally we are returning n minus answer because this is the shortest array that we can remove. And the only modification here is we have to find the total number of subarrays that can be removed. Here we have to find the least length, but now we have to find the total number of subarrays. So for example, if this is j and the lower bound we found for j is lb, and if we try to remove this, the condition will be satisfied, and if we try to remove this, even then the condition will be satisfied, because for example if it is 2 and if it is 3, 4, 5 and so on, and lower bound of 2 will be 3, so this is lower bound. If we try to remove this, then it will be sorted. If we try to remove this as well, it will be sorted because it is already sorted, and if this is greater than or equal to present, this will surely be greater than or equal to present. So we can remove this and we can remove this and so on as well till the last index n minus 1. So at index j with the prefix 0 to j in the final array, what are the number of possible subarrays that can be removed? It will be n minus 1 minus lower bound plus 1, because we can remove this, we can remove this, we can remove this and so on. So final minus initial plus 1. So n minus 1 minus lower bound plus 1 minus plus 1. It will be n minus lb. So answer will be the before answer, where we are traversing every prefix and we are using n minus lower bound, so that these are the number of subarrays when we are trying to keep 0 to j in the final array and removing some subarrays from j plus 1. And this is the answer. And let's say this is the prefix that is sorted, and this is some unsorted part, and this is the sorted suffix. From the base conditions before, we discussed that y answer is equal to max of answer comma n minus index, and y answer is equal to max of j plus 1. Here it is sufficient to find the shortest length, but here we have to find the total count. So let's assume that L is the least index such that L plus 1. So L is this, which is index same, and it is n minus 1. So this part is sorted. So we can remove the whole prefix till L. We can try to remove whole prefix with L minus 1 and so on. So that this is already sorted, and we are removing the first element, so that whole part will be sorted. So we can remove from L 0 to L, 0 to L plus 1 and so on till 0 to n minus 1. So final array is some suffix, so we are trying to remove this. So what is the count? It will be n minus L, because L to n minus 1 all will satisfy the condition. So the count in this is n minus L. And similarly we can try to keep some prefix, only prefix in the final array. So we can try to remove the whole suffix from this, whole suffix from this and so on. So this will be the final array, and this is sorted as well. So f is the highest index such that prefix is sorted, and if we try to remove the other part, the final array is some prefix. So this is the whole code is same, and we are trying to find f and g, because we want the highest index f such that the prefix 0 to f is sorted and 0 to f plus 1 is not sorted. And similarly L is the least index such that L to n minus 1 is sorted, L minus 1 to n minus 1 is not sorted. So if SS of 0, it means that whole array is sorted, and if the whole array is sorted, we can remove any subarray. So total number of subarrays will be n into n plus 1 by 2. And similarly we are finding index. So because index is same as L, but I am just writing this for clarity. So we can find index where it is the least index such that it will satisfy the condition. And we are traversing the whole loop, and if the prefix is sorted, we are finding lower bound of present value, and answer plus equal to n minus lb. And finally we are writing answer plus n minus l plus f 1 plus f, because this is this is the answer if we are trying to remove some middle subarray, and n minus l because we are trying to keep some pure suffix as final answer, and 1 plus s 1 plus f, and this when we are trying to keep the only prefix as final array. And it is given that we have to find the non-empty array, so we can just try to return n minus 1. So hope you understand this. If you understand, drop a like, comment below. See you in the next video.